Hi, in this video, we are going to start our discussion of ellipse. We have finished the theory and problem solving for parabola, and we'll start with ellipse now. So there are a lot of similarities between this curve and the parabola. Generally, all of it falls under the standard general conic, and we can say that if you have a general equation like this, 2gx plus 2fy plus c equals 0. In this equation, the condition for this to be an ellipse is del is not equal to 0, where del is the discriminant. We have studied that in previous videos. And also h square minus ab should be less than 0. If h square minus ab is less than 0, this curve, the 2-degree equation in x and y, will be an ellipse. However, this is not the form of the ellipse that most of the time you are familiar with. You will learn about, first of all, the standard ellipse. So what is the equation of an ellipse in terms of a locus of a moving point, right? So basically it is the locus of a point which moves such that PS by PM is equal to E, where E is a constant between 0 and 1. E is the eccentricity and PS by PM is the ratio of the distances. PS is distance of P x comma y from a fixed point, and that fixed point becomes your focus, which is S, and PM is distance of P x comma y from a fixed line, and that line is your M line. This is the directrix. If the ratio of these distances is a constant and that constant has a numerical value less than 1 and is positive, then that becomes your ellipse. Now, how do we get the standard equation of the ellipse? What we do here is we choose a nice line for a directrix and we choose a nice point for the focus. That will give us the simplest or the standard form of the ellipse equation. So if I choose my focus to be the point minus AE comma 0, and if I choose my line, the directrix line to be x is equal to minus A by E, in that case, where A is a constant, in that case, I do PS by PM is equal to E, and I will get the equation of the ellipse. So you can try it out. What you will get here is, let's do it on the next screen. PS is equal to EPM. So PS square is equal to E square PM square. And PS square would be the distance of X. So S is what? S is minus AE comma 0. And the line M is given by X is equal to minus A by E. So PS square would be X plus AE whole square plus Y minus 0 whole square is equal to E square, and PM square would be the distance of X comma Y from this line, which will be X plus A by E divided by root over 1, right? So this is the distance and we have to square this, right? So this becomes E square X plus A by E whole square on the right hand side, which is E square X square plus A square plus 2AX into E, right? On the left hand side, we have x square plus a square e square plus y square plus 2axe. So when you equate both of these, see what comes. The 2axe term gets cancelled and you have x square into 1 minus e square plus y square is equal to a square into 1 minus e square. And if we divide by a square into 1 minus e square on both sides, you get x square by a square plus y square by a square into 1 minus e square is equal to 1. And this equation here, this quantity is a constant. A square into 1 minus e square is a constant that is less than a square because we know that e square is less than 1, right? So we call this constant as b square. So we have b square is equal to a square into 1 minus e square. And we get the equation x squared by a square plus y squared by b square is equal to 1. Right? This becomes your standard equation of the ellipse. Here small a and small b are the lengths of the semi-major and semi-minor axis. And here a is greater than b, because we can see from here in the standard equation x squared by a square plus y squared by b square is equal to 1. We have a square into 1 minus e square is equal to b square, which implies that b is less than a. So this becomes your minor axis, basically the semi-minor axis, and this becomes your semi-major axis. And this is the standard form of the ellipse equation. Now, obviously, we'll understand the graph of the equation properly. But first, notice that from here, we can get the relationship on the eccentricity of the ellipse. We get b square by a square is equal to 1 minus e square. Therefore, e square is 1 minus b square by a square. So E eccentricity is root over 1 minus b square by a square, which is basically root over 1 minus semi-minor by semi-major axis length square. So the smaller axis, you have to divide that by 2, half of the smaller axis divided by half of the bigger axis, whole square. And if you subtract that from 1 and take a square root, that gives you the eccentricity, right? Now, what we will do is we'll try to understand the nature of the curve in more detail. So let's think about the standard curve x square plus a by a square plus y square by b square is equal to 1, where a is greater than b, right? So first of all, notice that if x comma y belongs to the curve, then x comma minus y and minus x comma y also lie on the curve. So notice that x comma minus y is the reflection of this point in the x-axis, whereas minus x comma y is the reflection of this point in the y-axis. So what this tells us that if you have one point on the ellipse, then the reflection of that point on the x-axis and y-axis will also lie on the ellipse. So the way to say that mathematically is that the curve is symmetric about both the x and y axis. So that is the statement that we can say. Also, you can also say that x comma y, if it lies on the curve, and it implies that minus x comma minus y will also lie on the curve. That also satisfies this equation. So the curve is also symmetric about the origin. Curve is symmetric about the origin. Why? Because actually minus x minus y is the reflection of x comma y about the origin, right? So what this also tells you is that since x comma y and minus x minus y both lie on the curve, every chord of the ellipse which passes through the origin will be bisected by the origin. Will be bisected by the origin. So this is basically the definition of center of the curve. The origin is the center of the standard ellipse because every chord that passes through the ellipse passes through the origin will be bisected by the origin. That comes because x comma y and minus x comma minus y are the two endpoints and the midpoint is the origin, right? So the ellipse is a central curve. It has a center. Notice earlier that we saw that the parabola was not a central curve. There is no one point on the parabola such that every chord passing through that point will be bisected by that point. right? So that is something that you should know. Okay, now let's try to think about the graph of the curve. So if you think about this situation where A is greater than B, let's find out where it meets the x-axis and the y-axis. So if you draw the curve, you will get a curve somewhat like this. This graph is not accurate, so I'll try to draw a better graph. Right. You will get a curve something like this. This is y-axis, this is x-axis, this is my origin. And you will see that when you put y is equal to 0, you will get x is equal to plus minus a. So these 2 points are a comma 0 and minus a comma 0. These are called the end points of the major axis. Basically, the longer axis is known as the major axis. So if you notice, this is like a flattened sort of a circle where this line is bigger than this line, right? So this becomes your minor axis and this becomes your major axis. And the length of the minor axis is 2b and the length of the major axis is 2a. And these points will come when you put x is equal to 0 in the equation, you will get y is equal to plus minus b. So it is 0 comma b here and this is 0 comma minus b. So these 4 points are the end points of the major and the minor axis, right? And these points A and A dash are known as the vertices. You can call this point A as A comma 0 and this point as A dash. That will be your two vertices and these are B and B dash here. That is the general way in which you represent these points, right? So length of the major axis is 2A, length of the minor axis is 2B. Okay. Also, what is the focus of this? Remember when we derived the equation, we already took the focus as minus AE comma 0, right? And there is a second focus to this curve, which is at AE comma 0. There are two foci to the ellipse, one at minus AE comma 0 and one at AE comma 0. And similarly, there are two directrices. This is the directrix line x is equal to minus A by E and another directrix line here x is equal to A by E, right? So ellipse and hyperbola are curves where there are two foci and two directrices. I will draw the figure again here to make it clearer. This is my standard ellipse. This is my center C. This is my focus S1 minus AE comma 0. This is the focus S2, which is AE comma 0. The directrix corresponding to the S1 foci is this, which is x is equal to minus A by E. And the directrix corresponding to S2 is this, which is x is equal to plus A by E. And these are the vertices, which is minus A comma 0, A comma 0, 0 comma B, and 0 comma minus B. So that is the general structure of the ellipse when the equation of the ellipse was like this, where A is greater than B. Notice it is important to say A is greater than B because then only the major axis is on the x-axis. If A was less than B, then the major axis would be the y-axis. So we'll see the equations of those types of curves. But before we do that, we will also define certain terms. So obviously, what is a chord? A chord is simple. Any line joining two random points on the ellipse is a chord, right? And similarly, what is a focal chord? Focal chord is a special chord that passes through the foci. So this would be a focal chord, this would be a focal chord, and so on. And similarly, what is the latus rectum? The latus rectum is a special focal chord that passes, that is perpendicular to the major axis. Focal chord perpendicular to the major axis, right? So which focal chord will that be? This will be the focal chord that is like this here. So the equation of the latus rectum, there will be two of them. One will be at x is equal to minus AE and one will be at x is equal to plus AE. So if you want, you can find out the length of the latus rectum also, which we'll do now. So if x square by a square plus y square by b square is equal to 1, and my equation of the latest rectum is x is minus ae or plus ae, if you put this into this equation, you will find the end points of your latest rectum. It will come out to be a square e square by a square plus y square by b square is equal to 1. So y square by b square is equal to 1 minus e square. And then y square is coming out to be b square into 1 minus e square. Now, if you remember, the result was e square was 1 minus b square by a square here. So therefore, 1 minus e square is simply b square by a square. So this becomes b square into b square by a square, and that is b power 4 by a square. So y becomes plus or minus b square by a. So the end points of this latest rectum are minus ae comma b square by a and ae comma b square by a minus b square by a, because the positive one will be the top point and the negative b square by a will be the bottom point. So the length of the latest rectum is coming out to be 2b square by a, and that is something that you should remember. Obviously, there are two latest rectum for the ellipse, and the length of both of them will be equal to 2b square by a, right? So that is a standard thing to know. Now, another important property of the ellipse is this. So let's think about it. You have, this is my ellipse, this is one focus S1, and this is another focus S2. And this is my directrix. X is equal to minus a by e. And this is the corresponding directrix. X is equal to plus a by e. These points are minus ae comma 0. And this point is ae comma 0, right? Now, very important property of the ellipse is that any point on the ellipse P, if you try to find the sum of the focal distance of P, S1P to S2P, right? You will always get S1P plus S2P is equal to 2A, which is the length of the major axis. Length of major axis. So how can we understand this property? Why is this happening? So think about it. S1P, if I have to find, by definition of the ellipse, S1P by PM should be E, right? And here I will say it is the PM1 because it is to this directrix. We know that the ratio of the focal distance to the directrix is going to be in the ratio of E into PM1, right? So I know that S1P is equal to EPM1, right? Similarly, S2P is the distance of this point to this focus. So it will also be in the ratio with this particular distance, which is PM2, right? So I know that S2P by PM2 will also be E. So we get S2P is equal to E times PM2, right? Now, if I want to add S1P and S2P, I will get S1P plus S2P is equal to E times PM1 plus PM2. Now notice PM1 plus PM2, these are perpendicular lines, so they are the same straight line because both of them are parallel to the major axis. So that is simply E times M1, M2. And what is the distance between these two parallel lines, the two directrices? That distance is simply E times 2A by E, right? Because these are at x is equal to minus A by E and plus A by E. The distance between them is 2A by E. And from here we get 2A as the length of S1P plus S2P, right? So what we get from here is another way to describe how to think of an ellipse, right? So what we can say is ellipse can also be identified as locus of a point, the sum of whose distances, the sum of whose distances from two fixed points is a constant k, is a constant k, provided the distance between the fixed points, the distance between the fixed points is less than k. So think about it. If you have two fixed points, these are the foci, right? The ellipse locus is such that P is a point where the sum of the distances is a constant k. This plus this. If it is always constant, then P will describe an ellipse, right? Now you have to ensure that S1P plus S2P is equal to K, and the K is supposed to be 2A, right? You have to ensure that this distance S1, S2 should be less than K, because actually the distance between the foci of an ellipse is actually 2AE, and E should be less than 1. So 2AE is less than 2A. So the distance between the two given fixed points should be less than K. And if P describes an equation, a locus where S1P plus S2P is equal to K, then that P will describe an ellipse, right? Okay, now what we will do is we'll look at, okay, before we go further, I should also point out that PS1 has come out to be what? PS1 was E into PM1, right? And PM1 would have been the distance of this point x1 comma y1 from the line x is equal to minus a by e, right? So PM1, the distance is what? It is x1 plus a by e, right? So the focal distance is coming out to be ex1 plus a, right? For PS1, correct? And what is the focal distance of P from S2? Now notice here that that is E times PM2, and this point was x is equal to a by e. So this distance would be a by e minus x1 and multiply that by e. So here the focal distance has come out to be a by e minus x1, multiply that by e, it becomes a minus ex1, right? So this is a very important thing to remember. Any point on the ellipse, it has two focal distances. Two focal distances depending on whether it is on the right half of the ellipse or the left half of the ellipse. And the focal distances are a plus ex or a minus ex, where this point's x coordinate was x. So this point's coordinate is x comma y. The focal distances are a plus ex and a minus ex. Remember, we had done something similar when we discussed parabola. And in parabola, I had said focal distance of x comma y was a plus x, right? And that fits in nicely with this. Here, e is not equal to 1. In a parabola, e was equal to 1. So actually, a plus ex works out there also, right? But here it is E is not equal to 1, and you have two different foci, so you have these two distances. You should remember always how to find the focal distance of any point from on an ellipse, right? There are two focal distances, and you can see clearly that the sum of them is 2a, right? A similar result will be also true for a hyperbola, where you'll get E x1 minus a minus e x1, ex1 minus a and ex1 plus a, something like that you will get, right? So we will see that as we go along. Now what I want to show you is the different forms of a parabola, the different forms of an ellipse. These are standard results and very similar to the standard ellipse. So far what we have seen is the first form, where this is my equation. This is x square by a square plus y square by b square is equal to 1. Here a is greater than b and b is obviously greater than 0, right? And here the center of the ellipse is 0, 0. The major axis is, this is major axis, y is equal to 0. Minor axis is x is equal to 0. The length of the major axis is 2a. The length of the minor axis is 2b. The eccentricity here is given by 1 minus b square by a square square root of that. The coordinates of the vertices are minus a comma 0, a comma 0. The foci are a e comma 0, minus a e comma 0. The directrices are x is equal to plus minus a by e. These are the directrices equations. There are two of them, one plus, one minus. The latest rectum equations will be something like this: x is equal to plus minus ae. These equations represent the two latest rectums. And that is all that you need to know about the standard ellipse form, right? Now we will look at a different form where a is not greater than b, right? So the second form is x square plus by a square plus y square by b square equals 1, where 0 is less than a and a is less than b. And here everything is reversed and y-axis becomes your major axis and x-axis becomes your minor axis, right? So here center is still 0, 0. Foci become 0, comma BE and 0, comma minus BE. The directrix lines become y is equal to plus b by e and the other directrix is y is equal to minus b by e. The latest rectum becomes y is equal to plus be and y is equal to minus be. The major axis is 2b and the minor axis is 2a, and the vertices are, this vertex will be 0 comma b, this one would be 0 comma minus b, this one would be minus a comma 0, this one would be a comma 0. Here the formula for the eccentricity is different. The eccentricity formula will be always 1 minus semi-minor axis by semi-major axis square. So here you should realize that the semi-minor axis is actually a, not b, right? So you will get 1 minus a square by b square here. This is the formula for eccentricity. You don't have to confuse anything here. It's always the smaller axis by bigger axis that is taken as a ratio and squared. So this is the standard information about the ellipse, which is vertical in the sense that the major axis is vertical, right? Again, now you can have situations where you have equations like this. This is also an ellipse equation. Here, let's assume A is greater than B. Everything is same here except the center of the ellipse has been shifted to h comma k. And because the center has been shifted, all the things in this ellipse will be slightly shifted, right? So let's understand what is happening. The center has gone from 0, 0 to h comma k, right? So my focus would be also not going to be ae comma 0. It would be ae plus h comma k, and it would be ae minus h comma k, right? Or not ae minus h, it will be h minus ae. H minus ae comma k, right? These are my foci. My vertices are what? This vertex would become h minus a comma 0, and this vertex would be comma 0, not 0, comma k, and this vertex would be h plus a comma k. The ends of the minor axis would be h is the x coordinate, so h coordinate that is same, and it is k plus b, and this is h k minus b, right? You don't have to remember anything here. You just have to apply your common sense. Everything has been shifted from the central position and brought here, right? So accordingly, we can write the equations of the directrices also. Directrix would be x minus h should be equal to plus minus a by e. So x would be equal to h plus minus a by e. That is the equation of the directrix, right? The eccentricity would be the same as before, 1 minus b square by a square, because the shape of the ellipse has not changed. All we have done is lifted it and put it somewhere else, right? So you should remember this. And obviously we could have flattened it and made it an ellipse like this, which is shifted, but with a major axis that is parallel to the y-axis also. So all of these are standard information that you need to know. Another thing that I wanted to talk to you about is you should understand this form. So if p x comma y is a point on the ellipse, x square by a square plus y square by b square is equal to 1. And here let's assume that a is greater than b. It's the standard ellipse, right? So one way to think of this equation of the ellipse is if you think of p as a point x comma y here, drop perpendiculars on the major and the minor axis. Let's say perpendicular on the major axis is m, the foot of the perpendicular, and the foot of the perpendicular on the minor axis is n. So think about what is this length and what is this length. You will realize that PM distance is simply y and Pn distance is equal to x, right? So the equation of the ellipse can be thought of as Pn squared by a square plus Pm squared by b square equals 1, right? Where Pn was what? Perpendicular from P to minor axis square divided by semi-major axis square plus this was what? PM was what? PM was perpendicular from P to major axis and whole square divided by semi-minor axis square is equal to 1. So this is a general way in which you can also write the equations of the ellipse. Why is this important for us? Because in a general case, sometimes they will not tell you the major axis and minor axis as simple lines like x-axis and y-axis. You could have a situation where they give you two perpendicular lines. L1 is a line like this, a1x plus b1y plus c1 equals 0. And L2 is a line like this, b1x minus a1y plus c2 is equal to 0. Notice that L1 is perpendicular to L2, right? And the major and minor axis is along these lines. They can tell you that major axis is along this line and minor axis is along this line, right? And if they ask you the equation of the ellipse in now, you won't have an easy way to write it in a standard form. So the way to do it is to think of a point P x comma y and think of the form that we just now discovered. Perpendicular from P to minor axis whole square divided by semi-major axis square plus perpendicular from P to major axis square divided by semi-minor axis square, that is equal to 1. That is going to give you the ellipse equation. So here, if this was my major axis, all I have to do is drop a perpendicular from here to here, drop a perpendicular from here to here, and put it in this equation, right? So what we will do here is x comma y. Here I need to drop a perpendicular to the minor axis. So to this axis, so I'll say b1x minus a1y plus c2 mod by root over b1 square plus a1 square whole square divided by a square plus here I will say a1x plus b1y plus c1 mod by root over a1 square plus b1 square whole square divided by b square is equal to 1. whatever equation comes from here is the equation of my ellipse, right? So notice that given any two perpendicular lines as the major and minor axis, we can still find the equation of the ellipse, right? Here the center of ellipse would be the point of intersection of L1 and L2. You have to solve this line and this line, the major and minor axis, the point of intersection becomes the center. And obviously, if the constant A is bigger than B, then this line is your major axis. And the constant B is bigger than A, then the other line is your major axis. So once you do a couple of questions, you will understand what I'm talking about. So let's look at one question here, which talks about this concept. So the question is, find the major axis, minor axis, center, and eccentricity of the ellipse 4 into x minus 2y plus 1 whole square plus 9 into 2x plus 5 plus 2 whole square is equal to 180. This is my question, right? So let's simplify this equation a little bit. We will divide by 180 throughout to make it 1 on this right side. So we will get x minus 2y plus 1 whole square by 45 plus 2x plus y plus 2 whole square by 20 is equal to 1, right? Now, if you think about perpendicular distance from some point to a line like x minus 2y plus 1 and all, the distance would have been x minus 2y plus 1 by root over 1 plus 4. This would be the perpendicular distance. So you would get a root 5 here, right? So if I square it, I would get an x minus 2y plus 1 whole square by 5, right? So notice x minus 2y plus 1 whole square by 5. That is what I am getting. This 5 is outside the square, right? So that is what I need to think of it as a perpendicular distance, right? So I have a 45 here. So what I can do is 1 by 9, and I can think of it as x minus 2y plus 1 by root 5 whole square, right? Similarly here, again I would get a root 5. If you notice, square root of 2 square plus 1 square is root 5. So I can write it as 1 by 4, 2x minus 2y, 2x plus y plus 2 by root 5 whole square is equal to 1, correct? So now we have discovered that this equation can be thought of as mod of x minus 2y plus 1 by root 5 whole square by 9 plus mod of 2x plus y plus 2 by root 5 whole square by 4 equals 1, right? So think about it. This is exactly fitting into our pattern of Pn square by a square plus Pm square by b square equals 1, right? And notice that in our standard ellipse, P was a point here. Pm was the perpendicular to major axis and Pn was the perpendicular to the minor axis, right? And we had Pn square by a square and Pm square by b square. Here a square is 9 and b square is 4. And it is clearly an ellipse where a is greater than b, right? So it's a standard looking ellipse, right? Something like this. However, Pn was perpendicular from point P to the minor axis, right? So our minor axis should be this line, right? Understand what we are doing? Our minor axis is x minus 2y plus 1 and our major axis should be 2x plus y plus 2, right? We are using this information, geometric information, to try to discover the major and minor axis. Also, a square is 9, b square is 4. So what are we discovering here? First of all, we know that a square is 9, so a is 3, so major axis is 6, b square is 4, so b is 2, so minor axis is 4. Eccentricity is, because it's a standard ellipse like this, where a is greater than b, eccentricity is 1 minus b square by a square. So 1 minus 4 by 9. So root 5 by 3 is my eccentricity, right? We also have to find the center. So we have discovered that minor axis was equal to the first line, x minus 2y plus 1. And major axis was the line 2x plus y plus 2. So if you solve these two together, what you will get is the center of the ellipse, right? So center of the ellipse will be the intersection of these two, and that comes out to be minus 1 comma 0. So center of the ellipse is this. Major and minor axis have been found, and eccentricity and the length of the axis also has been found, right? So understand this pattern. You have pm square by a square plus pm square by b square equals 1. As long as n and m are lines that are perpendicular, these will be the major and minor axis, and p is a random point on the ellipse, right? Okay. One last thing that I wanted to discuss in today's video for the ellipse was position of a point with respect to an ellipse. Position of a point with respect to an ellipse. So this is a simple idea. The ellipse is a closed curve, and we can say that if the equation of the ellipse is this is the standard equation of an ellipse. If you have a point inside x1 comma y1, if you put this point in the equation of the ellipse, you will get x1 square by a square plus y1 square by b square minus 1, and that quantity will be less than 0. And if that quantity was greater than 0, then p is outside. So if x1 squared by a square plus y1 square by b square minus 1 is greater than 0, then the point is outside the ellipse. And if the quantity was equal to 0, then obviously the point is on the ellipse, right? So these are standard facts that are true for most of the situations that you will encounter. For most of the curves, circle, parabola, also we had similar results. In the next video, what we'll start doing is equations of tangents and normals and the standard information that you need about this particular curve. So we have a few more videos to cover the entire theory, but hopefully in today's class you have understood the basic meaning of an ellipse, the different ways in which you can think of the standard equation of the ellipse, and learn how to identify the basic properties of the curve. All the facts like major axis, minor axis, eccentricity, shape of the curve, directrices, and how to think about the ellipse in the case the axis is not the simple x and y axis, but it is given as two different parallel lines. So that case also we discussed at the end, which is super important. Go through the video properly. If you have some questions, feel free to type in the comments and tell me. I will try and explain it in the future video. And this begins our ellipse series. We will do 3-4 more videos to cover this topic fully. And you should expect it to be done in the next few days. So go through the videos and try and learn what we are doing. Also, please like and subscribe. Like the video, subscribe to the channel, and help me grow the channel. I'll see you next time.